In the previous class we have learned about the Ohm's law. So today we will learn about the resistance. Now, definition I have written here. What is a resistance? Resistance of a conductor is its property to oppose the flow of electric charge through it. This oppose property, these are the things that you need to remember, okay? To oppose the flow of the electric charge through it. Okay? Now, resistance of a conductor, okay, means, see, a conductor, in a conductor electric charge can flow, electric current can flow easily, okay, but resistance is something which will oppose the flow of the electric charge in a electric current in a conductor. That means in a wire, in a conductor, the electric current cannot flow. Resistance oppose the flow, okay, resist or see, oppose, there are different words but has the same meaning. Oppose, you can say resist, or you can say hinder, or you can say interfere. So many words are there, okay? So whichever word is easy for you to understand. So resistance of a conductor is the property to oppose, resist, interfere or hinder. So it means in a wire, in a conductor, the current cannot flow easily. They were disturbed by something, okay? The flow of the electric charge through it. Okay? So it resists the flow of the electric charge. Now, from the Ohm's law, we know that V equal to IR or R equal to V by R. Okay, this relations we have taken from the Ohm's law. But before we understand this one, okay, now let's go to the opposed and resistance. What happens in the conductor that makes this electric current flow slowly or difficult to flow, or it was resist? Because the collisions of the charges. What are the charges? The electrons. The particles which are moving in the conductors, they cannot move easily because of the collisions or hindered. So if there is a disturbance in the flow of the electric charge, definitely there will be a disturbance in the flow of the electric currents. Because electric currents, we get it from the flow of the electric charge. If the electric charge is not flowing freely or unable to flow easily in a conductor, definitely the output of the electric current, the flow of the electric current is going to be less, or it will be difficult, right? Now, from the Ohm's law, V equal to IR or R equal to V by R. Okay, so we can find out the resistance of a conductor by using this relation. The another definitions of this resistance is the ratio of the potential difference. So, ratio of the potential difference. Potential difference I have written in the short form PD, okay? Across the ends of a conductor and to the electric current. So, the electric current, so the ratio between this potential difference in the electric current is also be known as the resistance of a conductor, okay? So, you can use these definitions when the questions ask define resistance or what do you mean by resistance. You can write this answer or this answer, both are same, okay? Either you can explain in the form which resist, oppose, or which disturb, or which do not allow the electric current to flow easily, that is resistance. Simply you can write, or you can write the ratio between the potential difference and the electric currents which is flowing in a conductor. That ratio is the resistance. So either both you can use. So resistance, it is a scalar quantity, okay? Now see, from Ohm's law, we know that, we'll take directly this one, we'll not write this one, okay? So R equal to V by I. V is the potential difference, volt, and I is the current, right? So the SI unit of resistance. So what will be the SI unit of resistance? The SI unit of resistance will be the SI unit of this potential difference in the current. SI unit of potential difference is what? Volt, right? Which is V. What is the SI unit of current? I. Ampere, right? Which is capital A. So the SI unit of resistance will be the volt by ampere. So which is known as the ohm. Okay, and it is denoted by the symbol, Greek letter. This symbol we call it omega. Okay. So SI unit of resistance will be the SI unit of potential difference, the SI unit of the current, which is ohm, and we write this symbol. It's a Greek letter known as omega. Now the resistance is clear. So now we will study about the factors on which the resistance of a conductor depend. Now these questions might ask, okay, define 1 ohm. So that's the reason I have written this definition. What is 1 ohm? It's nothing. Resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through the conductor by applying a potential difference of 1 volt across its ends. So let's say we have a wire. This is a wire. This is a conductor. Okay. In this conductor, if 1 ampere current flows, okay, if 1 ampere current flows in this conductor by applying 1 volt of potential difference, then we can say that this wire has a resistance of 1 ohm. Very easy, okay. So this definition is very easy. This question is also very easy, but it is asked in the exam. Define 1 ohm, or what do you mean by 1 ohm? Okay, it's nothing. In a conductor, if 1 ampere of current flows by applying a potential difference across these ends of 1 V, then we say this conductor has a resistance of 1 ohm. Okay. Now you can write down this definition. Okay. Now we'll learn about the factors on which the resistance of a conductor depends. Okay. So factors on which the resistance of a conductor depends. One, we have length of the conductor. Okay. So what do you understand by this? Factors on which the resistance of a conductor depends. Means, what is the resistance of a conductor? There are different types of conductor. We have copper wire, aluminum wire. We have. Okay. So what are the resistance of all this conductor? So it depends on this factor. There are some factors. Okay. Number one factor is length of the conductor, which means that, let's say this is a conductor of length this. This is our conductor. Okay. So we have another conductor here with A has, B has. Between these two conductors, from the first conductor, the second conductor is longer. So resistance of a conductor depends on the length of the conductor. So first is the longer the conductor, means if the length of the conductor is greater, then we have a high resistance, more resistance. So resistance is directly proportional to the length of the conductor, which means the longer the length of the conductor, the more the resistance. The shorter the length of the conductor, the less the resistance. So resistance depends on the first factor is the length of the conductor. Okay, so it's directly proportional. So if you keep increasing the length, the resistance keep on increasing. If you decrease the length, the resistance will decrease. So which is directly proportional to the length. Okay, which is directly proportional. Now the second factor is the area of the cross section of the conductor. Area of cross section of the conductor. Okay, these factors are very easy. Okay, so what do you mean by the area of cross section? So again, let's come back to the same conductor. So this is the conductor. Okay, another conductor here. So we have two different conductors. Here what happens? Resistance of a conductor is inversely proportional to the length of the, inversely proportional to the area of the cross section. Or simply you can write by capital A. Okay, so area of the cross section. So resistance of the conductor directly proportional to the length, and it is inversely proportional to the area of the cross section of the conductor, which means that this is a conductor, this is the area, the diameter you see here. Okay, so what happens here? If the area of the conductor or the diameter is larger or greater, bigger, what happens? That conductor will have less resistance, which means inversely proportional to the area. Okay, because see here, how do we get electric current? When the charges flow. So these are the two examples. So in this conductor, how many charges can fit here? What do you think here? Maybe hardly like this. Okay, 2 or 3. When these charges start moving, then we get current, right? But in this wire, in this conductor, you see the diameter, the area. Okay, it's larger than this one, bigger. So many charges can flow here, fit here. Means large amount of number of charges will move here. For example, we have a pipe of this diameter, of this area, and another pipe which is greater. And we have a bucket here, two different buckets. We have one bucket here, let's say 5 liter, another bucket we have 5 liter here. So if we release the water at the same time, which bucket will fill faster? The second bucket. Okay, because the area of the pipe is bigger, so more water will flow. The pipe here, the area of the pipe here is small, so less water will flow. So the second bucket will fill faster. So in the same way here, in this conductor, the area of cross section is small, and here the area of cross section is larger. So from compared to this, more charges will flow here. If more charges flow, we'll get more current. There will be less resistance. So less area of cross section means less charges will flow. We'll get less current. So this will have high resistance. This will have less resistance. Okay. So when a area of the cross sections of the conductor is large, then it is inversely proportional. Okay. And the third factor we have is the temperature. Okay. So I'll write in short here. Resistance of the conductor increase due to the increase in the temperature. Okay. So if temperature is increased, resistance R is increased. If the temperature is decreased, resistance either will remain the same or it will decrease. Resistance will decrease. Now, what are the reasons behind this? One example I'll give you. Let's take just one example, okay, a simple example. during the winter seasons, what happens to the railway track? Let's say we have this railway track. It appears shorter, this track, during the winter because the temperature goes down. Okay, but during the summer time, it becomes longer because the temperature increases. Okay, this is the real example, right? Same way, if the temperatures of a conductor increase, what happens? There is a chances of increasing the length of the wire. So when the length of the wire is increased, there is a chances of increasing the resistance of a conductor. Depends on the first factor. Okay. So if the temperature decrease, the resistance, the conductor remains the same. The size will not become small. Okay. It will remain the same. So the resistance of this conductor will be the same. But when the temperature increases, the length might become longer. Then the resistance will become high. Okay. So this is the third factor. Now the last one we have is the fourth one. Nature of the material. Nature of the material. So we have four factors here. Nature of the material means what is this conductor made with? Okay, what is this conductor made with? With what material this conductor is made? Okay, so resistance, that material has a high resistance or low resistance, depends on the material, okay, of the conductor. Now, for example, copper wire, okay, and aluminum. I'll give you one example. So we have two conductors, copper and the aluminum. Let's say our first diagram is the, let's say this is the copper wire, okay. Now we have another wire conductor here, conductor 2, which is the aluminum. Two diagram, okay. So, two example, copper conductor, this one, and the aluminum conductor. Now let's satisfy all the dimensions, configuration. So this conductor has a length of this, that's a x, and this also has the length. So these two has the same length. The area of cross section of this conductor and the area of this cross section of this conductor are same. So aluminum conductor and the copper conductor has the same length, same area of cross section, and same temperature. Let's say all the three configurations are equal, same. But even though all the three configurations are same, the resistance of these two conductors will be different because it is made with different materials. Okay. So resistance of a conductor depends on the nature of the material also. Okay. Now let's say the first factor, length of the conductor, directly proportional to the length. Let's say this is equation 1. Okay. And then we have inversely, second factor, inversely proportional to the area of cross section, which is equation 2. Okay. Inversely proportional to the area of cross section. Let's say this is our equation 2. So if we combine equation 1 and 2, we get the relation here, resistance inversely proportional to the directly proportional to the length and inversely proportional to the area. Okay, so this is one relation we have. When there is a proportionality, we can replace this proportionality by equal to a constant, and this constant is, this is the constant of proportionality. and this is, we call it rho. This is the constant of proportionality, and it is the resistivity of a specific resistance of a conductor. So this is, we call it rho. Okay, when there is a proportionality, we can replace this proportionality by giving a constant which is called rho equal to constant of proportionality, and this is, rho is the resistivity of a specific resistance of a conductor. Okay, now let's solve two examples. Okay, very easy examples from the previous, from what we have learned till now. Okay, so the first example is, how much current I will an electric bulb draw from a 220 volt, okay, source. So this is potential difference PD of 220 volt, okay. So how much current? So we have to find out the I. If the resistance of the filament of the bulb is 1200 ohm, so we have to find out the current. So what are the things given? That one we have to first see. Let's see here. What are given here? I not given. Okay. So we have to find out. So we have a potential difference of 220. So V, how much? 220 volt is given. And then R is given. This is resistance. Ohm. This resistance R is given. How much? 1200 ohm. How much current? So I we have to find out. It's not given. And we know from Ohm's law, we know that from Ohm's law, V equal to IR, right? So if you find out I, then it will be V by R. So let's put this value here. V is how much? Where is it? 220, and R is 1200. So 0 0 cancel. So if you divide this one, you will get 0.183 ampere. Okay. So how much current will an electric bulb draw? It will draw a current of 0.18 ampere. Very easy, very simple. Okay. Now this is our first example. Second one, potential difference between the terminals of an electric heater, okay, is 100 volt. When it draws a current of 2 ampere, current I V here 100 volt and current 2 ampere. Okay. So what it means that what does it mean? It means that let's say we have an electric heater. I'm just drawing an example, okay? So let's say this is an electric heater. So on these electric heaters, on these two terminals, A and B is the two terminals. If 100 volt potential difference is applied, then it will draw a current of 2 ampere. Okay. So So if you apply a potential difference of 100 volts on this heater between these two terminals, this heater will draw a current of 2 ampere. Okay. What will be the current? Which means what will be the current? Which means it will be a new current. Okay. It will be the new current. If the potential difference between these terminals is increased. So if the potential difference between is 100, now if I change the potential difference from 100 to 140 volt, will the current draw by this electric heater will be the same? No. There will be a new current. It will draw a new current. What is that current? We have to find out. Okay? What is the new current? We have to find out. Okay? So this is for the first question up to here. And this is for the second questions from here to here. Let me go back one more time. This is an electric heater. So in this electric heater, if you apply a potential difference between these two terminals of 100 volts, this electric heater will draw a current of 2 ampere. Okay. Now, if you change the potential difference from 100 to 140, increase the potential difference, the current will not same. There will be a new current, right? So it will draw a different current. So what is that current? We have to find out. The second question, second part. So what happens? From the Ohm's law, we know that V equal to IR. But in the second questions, there is no R given here. V and I. We have V only 140. We have to find out I. But without R, we cannot find out I. So we have to find out the resistance of this electric heater first. Because it is the same electric heater. I did not change the resistance, or I did not replace the electric heater. Same electric heater, which was taking a potential difference of 100 volt and drawing a current of 2 ampere. Same electric means the resistance will be the same. So I have to take out the resistance from this heater. What is the resistance? So then I will use this one, right? From Ohm's law, V equal to IR. So if I take the resistance, what is the resistance of this electric heater? Then I have to use this value. Then I'll get the resistance. So R equal to V is how much? 200, right? 100 volt. And then I is how much? 2 ampere. So if I divide it, I'll get it 50. So the resistance of this electric heater is 50 ohm. Now I have R equal to 50 ohm. Now I can find out I. Okay? Understand? So I can find out the new current, right? So again, we know that V equal to IR. So I have to find out new current, right? I equal to, it will be V by R. So V is how much here? It increased to 140 volt. R is how much? 50. We get it, right? So if you divide this, you will get, let me rub the lower portion first, okay? Let me rub this question. So if you divide this one, you will get a current of 2.8 ampere. Okay, therefore the current, let's write simply, okay? Therefore the current I equal to 2.8 Okay. So on giving the potential difference of 100 volt on the same heater, it draw a current of 2 ampere. But if you increase the potential difference to 140, the current also increase. It becomes 2.8 ampere. Okay. So in the next class we'll do more numerical problems. Okay.
Stay home, stay safe.
Do it for self.
Do it for your family. Do it for India.
Let's break the chain of COVID-19.
हम होंगे कामयाब, जय हिंद। हम होंगे कामयाब, जय हिंद।
हम होंगे कामयाब। जय हिंद।